Hi, today we're going to be talking about section 2.7, parent functions and transformations. We're going to talk about what the different parent functions are that you need to know, at least at this point, and then how they transform. So transforming includes translations, which is when a graph shifts left and right or up and down. We're going to talk about reflections. When a graph reflects over the y-axis or reflects over the x-axis. We're going to talk about dilations, which is another way of saying how does it stretch or shrink. All right, and then how we can identify and then write equations for these transforming functions. Okay, what I'd like you to do first is I would like you to graph these four parent functions. This is the parent function y equals x, the parent function y equals x squared, y equals absolute value of x, and y equals 1. These are the first four parent functions that you're going to need to know, that you should just be able to, right off the bat, draw the graph or know exactly what it looks like. So if you don't already know, make a table and graph the table so that you can figure these out, but these should be pretty quick and easy for you to graph. So go ahead and graph these four and hit pause. Okay, the graph y equals x. Well, I know if I was making a table, it would be -5. If I plugged in a -5, I get -5. So points would be -5, -5, -4, -4, -2, -2, 0, 0, 2, 2, 4, 4. They all match. So what that does is it creates, let me see if I can draw instead of move. It creates this line, and it should be a straight line. Sorry, mine's not perfectly straight there, but it should be a straight line at a 45-degree angle that crosses at 0, 0. Another way you could think of this is really the parent function y equals mx plus b, where m, the slope, is 1, and b, the y-intercept, is 0. So this is just the parent function for any line. Really, skipping down to the fourth one, including this fourth one, y equals mx plus b, well, it would be a y-intercept of b and a slope of 0 because there's no x here, so 0 times x, that goes away. So this one would just have a horizontal line because it's a slope of 0 crossing at a y-intercept of 1. Okay, so both of those truly have the parent function of y equals x, but a lot of times you'll think of them as two different parent functions because the graph y equals 1 is just the constant 1 there. Okay, y equals x squared. Hopefully you know that's a parabola. If I start at 0, 0, I know that 0 squared is 0. I know that 1 squared is 1. I know that 2 squared is 4. And 3 squared is already off. So 1, 1, oops, I missed. Sorry, I'm having a hard time drawing this. There's 4, and then I'm off the graph. So it makes this thing that's called a parabola. Okay. That parent function is also known as the quadratic function, okay, y equals x squared, and it makes a parabola. So hopefully you remember that from Algebra 1. Then the third graph, y equals absolute value of x, well, we've already done that, and it gives you for all those negative values, they become positive, okay, and then it's just like from 0 up to infinity, it's just like the y equals x line. So it makes that v, it crosses at 0, 0, so it makes that nice v there. So those are the parent functions that hopefully you drew. You need to have these memorized. You need to know all of these by heart. This should be something that's second nature. If you don't have these down, you should be able to instantly, when you're shown a flashcard of these graphs, be able to say, that's the graph y equals x. That's the graph of x squared. That's the graph of absolute value. That's the graph of y equals whatever the constant is, in this case 1. So really you have to know those parent functions. So if you don't, memorize them now and draw them over and over a few times. Okay, we're going to now take these parent functions and we're going to transform them. We're going to stretch them, we're going to shrink them, we're going to shift them up and down and left and right, and we're going to reflect them. Okay, I'm going to teach this a little bit different than your book, just because this works for every single function. And when we get to trigonometric functions, I think it makes it way simpler doing it this way because you'll already be used to it. So this method will work for everything. Now, for both ways, your book's going to have two different ways, and I don't like learning two different things for the same idea. So the regular form for transforming functions is y minus k over b equals f, that's the parent function, of x minus h over a. Okay? An example of when we could get it to this form, if we started off with this function, let's say it said y equals something like 2 times x minus 2 over 3 squared plus 1, something like that. Okay? We would want to get it into this form, because once we're in this form, every time, as long as we're in this form, we're going to have some rules that we can follow that will tell us what's actually happening to this function. So I need to get anything that's not inside the function, the x squared function, that's f of x. So I guess the very first thing I need to define here would be my parent function is, I'm talking about f of x equals x squared. So make sure you do that. But then we need to get anything that's outside of that function away. So the 2 here is outside and the plus 1 here is outside. So to get rid of that plus 1, I subtract both sides by 1. So I'd have y minus 1, and then to get rid of that 2, I divide both sides by 2. So it would be y minus 1 over 2 equals x minus 2 over 3 squared. Okay? So then we can talk about how this thing is actually going to shift. So if we go back to this form, y minus k over b equals f of x minus h over a. If I'm talking about that form, I need to identify, well then what is h? Okay, h, it's with the x's, so it's going to be horizontal because x is horizontal. So h is the horizontal translation. Which is just a nice way to say shift. So translations means shift, so I'm just going to put slash shift. How does it move left or right? Horizontal translation, how does it shift left or right? Okay, k then is equal to, that's with the y value, so that has to be a vertical, because y is vertical. Translation, which means just how does it shift up and down. So h, it's with the x value, k is with the y value, so you can just remember which one's horizontal, which one's vertical. The one that's with the x value is horizontal, the one that's with the y value is vertical, and the one that it's the number that's being added or subtracted, so that's going to shift it. That's going to shift a function. Okay. A is again with x, so it's also horizontal. But it's dividing. Okay, when you're dividing a number, that's going to stretch or shrink a function depending on what it is. So A is the horizontal stretch or shrink, which your book calls dilation. I call it stretch, okay, or shrink. B, well, B is with the y value, so it has to be vertical. So B is vertical. Dilation, which again we call the stretch or shrink. Okay. Along with that, if you have a negative sign with A, so if we had a negative A, that is going to reflect. That's going to reflect a line. And A affects the x values, so if the x values change from positive to negative, that will reflect it over the y-axis. So it will reflect over y-axis because the x, it affects the x values change from positive to negative, that reflects it over the y-axis. If we have a negative b value, that reflects the parent function over b affects the y values. If the y values change from positive to negative, that reflects it over the x axis. Okay, so if we just stick with this, we can describe how any parent function is going to transform. So again, going back to this example, if we were to look at this, I can identify, now that we're in this form here with it, I can identify that h, it says x minus 2. So h has to be equal to 2. Okay, k would have to be equal to 1 because it's minus k, so minus 1. All right, notice those are opposite. Notice how my h and k are positive, but in the equation that they're opposite in sign there, an opposite in sign there. Okay, that's how h and k work. When they're opposite, and you have to make them opposite in sign because it's y minus k and x minus h. Okay, the a value here is equal to, a is with x, so that's 3, and b is equal to 2. All right, so that tells me this has a horizontal shift, or since it's a positive 2, it's going to shift right 2. Okay, and this is the parent function we're talking about, x squared. So x squared is going to shift to the right 2. It's going to shift up 1. Okay, a is 3. If we think of it as a multiplier, if you're multiplying something by 3, it's going to stretch by a magnitude of 3. So it's going to stretch horizontally by 3. If I do that with 2 arrows on the outside. Okay, and it's going to stretch vertically by 2. Okay, so that's a little bit of a harder concept. Here's an extra piece. Okay, well, notice also that a and b were both positive, so it does not have a reflection. All right, so again, looking at this, this goes right 2, up 1, stretches by a factor of 3 horizontally, and stretches vertically by a factor of 2. Now, if a or b are between 0 and 1, meaning like if it was 1/2, if we got 1/2 for a, instead of stretching, that will shrink it. So anytime the a or b is between 0 and 1, that's where we get the shrink part. Okay, if it's greater than 1, it stretches. If it's between 0 and 1, it will shrink it. Okay, so that's a real quick, well, not very quick, 8 minutes long. That's an overview of how we're going to look at transforming functions. So let's start getting real with it. Identify the function given by the graph. So I want you to just identify what is the parent function that these graphs are talking about. And then if you really want to challenge yourself, try to write the equation of the graph too. So go ahead and hit pause for both of these. Okay, hopefully right off the bat you can just look at this first graph and identify that that is a parabola, meaning that the parent function has to be y equals x squared. Okay, but if we look at this a little bit closer, we can see this is not going through 0, 0, so this thing has shifted up 2. So that means if we're going to our y minus k over b equals x minus h over a. All right, well, since the parent function is x squared, we're just going to square that. Notice the only thing this thing has done is shifted up 2. It hasn't shifted horizontally, so we don't have an h value. A and b, it hasn't stretched or shrunk vertically or horizontally, so a and b are just 1. But k is equal to 2, so this would be y minus 2 over 1 equals x squared, because it's x minus 0 because it hasn't shifted horizontally over 1. So this just leaves us the x squared. So if we were to solve this for y, by adding 2 to both sides, we'd get x squared plus 2. That is what the graph there is. Okay, the second one, if we look at that, that's a line, so we know our parent function is y equals x. So that's the parent function that we're talking about. Okay, this one's a little bit harder. So if we look at this, this thing has shifted. We could look at it a bunch of different ways, but the easiest one for me to see is I'm just going to say it's shifted down 3. Okay, so that would mean my k value equals negative 3. Okay, I want to choose that specifically just so you can see what's going to happen with the equation. But it's also stretched. We could either say that it's been stretched horizontally. If we pulled both sides, we could say it's stretched horizontally. Normally this thing goes over 1, up 1. Well, now it goes up 1 over 2. So A is the horizontal, that was a 2. B is the vertical, that was the 1. So B is still 1. K is 2. H, it hasn't, we're going to say this thing hasn't slid horizontally. So we're going to say H is 0. Now, you could say H has been, you could say K is equal to 0 and H is 6. That's fine, it'll give you the same thing. But I chose specifically this time to say that it went down. There's actually, with lines are hard because there's an infinite number of ways you could say that. You could say it was right 2, down 2, hitting right there. You could say a bunch of different things. Okay, but I'm going to go with it hasn't shifted horizontally, it's just shifted vertically down 3. So if I go to my equation, that's going to be y minus negative 3, makes it plus 3, over b is 1, equals, the function is just x, so we don't have to do anything outside of the parentheses here. But then x minus h we said was 0, over 2. Okay? So if I wanted to, well really I don't need that 1, because if we're dividing by 1 it's the same thing, so we need to subtract that y over it. Really it would become y equals x over 2 minus 3. Now your book would probably make it y equals 1/2 x minus 3, which is easier to see that that has a slope of 1/2 and a y-intercept of negative 3. Okay, the biggest thing that you pulled out of both of these two is that you identified the parent function as an x squared here, and that the parent function here is y equals x. Next, we need to describe what happens to these functions. Okay, so if you would like to, I want you to do both of these. If you would like to, if you need to make a table, go ahead and make a table. But I challenge you, try to identify what is your h, what's your k, what's your a, and what's your b, what's your parent function, and then try to draw the graph just using that information. So I'm going to try to challenge you to do it that way. And then maybe make a table and see if it checks out with what you made. So go ahead and pause and try that. Okay, so if I'm looking at this, all right, I would say that in the form y minus k over b equals f of x minus h over a. The first thing I identify, what is the parent function, f of x? Well, f is the absolute value of x. So we're talking about the absolute value function. I know that's the v shape, and it crosses at 0, 0. All right. I also notice there's nothing outside the function itself, meaning that there's no k value and there's no b value. Everything's happening right inside the function, so that's affecting specifically the x value. So I know k equals 0 and b equals 1. All right. I see a lot of people mess that up and they say b is equal to 0. It's b if nothing's happening. All right, dividing by 1 is the same thing as whatever the number is. Okay, subtracting 0 is the same thing as if there's nothing happening. All right. Now h, though, h equals, now look, it's x minus h, and this says x plus 3, so it has to be opposite. So h is negative 3, because if we were to plug it back in here, x minus a negative 3 is the same thing as x plus 3. Okay, and then a is again just 1. So this, the only thing that's happened is this has shifted left 3 because h affects the x value, so it's a horizontal shift. It's negative 3, so it has to be left 3 because negative and left are how we talk about terms in math. Down is negative, left is negative, so left 3. So if I was to just quickly draw my graph, the parent function normally looks like that. Well, this one I need to go left 3, so that's negative 3, and it's going to have the exact same shape. So it's going to be the v, it's just going to be over to the left 3. Okay, so hopefully if you made a table, you would see those numbers work out that same way too. Okay, for the second one, y equals x squared minus 4. Again, if we broke it down to, okay, what does it look like in terms of y minus k over b equals the parent function of x minus h over a. All right? Well, if you look at this, inside the x squared, there's nothing. There's nothing inside that x squared. So that tells me that h equals 0 and a equals 1 because there's nothing happening inside that function. All right? But I'd have to move that 4 over. Okay? So it really should change to y plus 4, all right, over 1 equals x squared. All right? Telling me that k then has to be a negative 4. Remember, it's y minus k, and we got a y plus 4, so to get that to be a plus, you have to do y minus negative 4. So k is negative 4, and b is 1. Okay? So you really, again, when we don't stretch vertically, you don't really need that 1 there. So it's just y plus 4 equals x squared, telling us since our k value is a negative 4, we know k is vertical, so that's down 4. So here, I would just take a look. I've got my parent function of x squared. I know that's a parabola. Okay, I need to shift that parabola down to negative 4. So I would draw my parabola the same shape. It's just going to be down 4. So that's a really quick way to be able to translate or shift that function down 4. Okay, so that was just shifts. That's translating a function. Okay, shifting, translating. So notice our h and our k values were the only thing that were affected there. Okay, reflecting a function. So this time, if we look at this, well, I want you to give this a shot. Either make a table or try what we just did. Try to identify a, b, h, and k and see if you can figure out what this looks like, and then compare them to the function and then graph them. Okay, hopefully you gave that a shot. If I look at this, again, there's nothing inside the x function, so I know that in the form y minus k over b equals f of x minus h over a. Okay, if I look at that, nothing is inside the absolute value function. So f, first off, is f of x is the absolute value of x. That's my parent function that we're dealing with. And if I was just to draw that parent function right now, absolute value is that v-shaped function. Okay, so we're gonna reflect that. We need to find out how it's gonna reflect those. So again, that negative sign is outside the parentheses. It really needs to go to the y value. Okay, to do that, just divide both sides by negative 1. So we would get to y divided by negative 1 equals absolute value of x. So if we look at that, that tells us, number one, h and k are equal to 0. There was nothing added to either side. Okay, a, there's nothing with the x, is also equal to 1. Nothing's happened there. B, though, b is equal to negative 1. If we remember back before, when b is equal to negative 1, that negative is with the y. If we're going to make all the y values negative, right now, all these y values are positive. Okay? If I'm coming here, all these y values are positive. If I need to make those negative, then they're just going to flip and go down. So all those would go down here, and on the other side, all those y values would come down here. That's how this would reflect down. That is the function y equals negative absolute value of x. Okay? Hopefully for the next one you did the same thing. You could do this one either way. You could say that negative value is with the x, or you could say it's with the y. It doesn't matter in this case because it's just a line. And we know that the parent function normally looks like that. All right, if you made all those x values negative, so if we were looking at all of these x values, those are all negative right now. If we flipped those and made them all positive, it would come down this way. Okay, and if we made all these positive x values negative, it would come this way. So it's going to make this line here. Oops, that should have crossed at 0, 0. Okay, so hopefully that's what you got as far as reflecting these functions. Okay, now we're going to stretch or shrink a function. So we're talking about the dilation of a function. So see if you can hit pause. Remember, if it's not with the x inside the function, it's with the y. So that should tell you how you need to stretch or shrink this. Okay, So number one, hopefully you identified the parent function, f of x is equal to x squared. Okay, that 2 is not inside, it's not parentheses 2x close parentheses squared, so that 2 really needs to get moved over to the y. So it needs to become y over 2, because to get rid of multiplying 2, we divide by 2, equals x squared. That tells me that h and k are equal to 0. It hasn't stretched it hasn't shifted at all. There's no addition or subtraction here. So they're equal to 0. Okay. The a value, there's nothing with x, so a is equal to 1 and b is equal to 2. So this will take the x squared function and it will stretch it vertically by a factor of 2. So this gets a little bit harder, and to graph this I need to be a little bit more careful how I draw. So I'm going to say 1, 2, 3, negative 1, negative 2, negative 3. Okay, and since I'm squaring, that's normally 9, but 9 times 2 is 18, so we'll go up to 20 here. Make that 10, 15, and 5. Sorry, that 5 should probably be right there. Alright, so normally the parent function's at 0, 0, then at 1 it's at 1, 2 it's at 4, 3 it's at 9. Okay, so we've got this function here. This is normally my parabola. Sorry about that interruption. So if I was going to take each of these points and stretch them vertically, so again, this was at the parent function that I drew. Okay, 0, 0, 0, 0. Then we're at 1, 1, because 1 squared, oh, that was a bad one, 1, 1. Okay, 1 squared is 1. Then we're at 2, 4. Then we're at 3, 9, because I'm just squaring all those. Same thing over here. Negative 1 squared is 1. Negative 2 squared is 4. Negative 3 squared is 9. Okay, here's an easy way to do it. Take all these values, all right, and just multiply the y value by whatever b is, and multiply the x value by what a is. So 0 times 1 is still 0, 0 times 2 is still 0, so this transform function is going to be at 0, 0. Then 1, 1, 1 times 1 is 1, but 1 times 2 is 2, so it's going to go up a little bit higher. Okay, instead of 2, 4, 2 times 1 is 2, but 2 times 4 is 8, so it's going to go over 2 up to 8. So that would be that point. And then instead of 3, 9, it's going to be 3, 18. Okay, same thing on this side, you can kind of just reflect that over. So we get this parabola that if we were to grab it like it was on Play-Doh and stretch it vertically, that's the new shape that we would have. That's been stretched vertically there. Okay, more realistically, most of you probably drew it on a graph that looks like this, where your parent function looks closer to that. Okay, that's great and that works, and it would just get a little bit skinnier looking like that. So that's probably closer to what your graph looked like if you did it correctly. Okay, the next one. All right, that is inside the function. Multiplying by 1/3 though is the same because we want it to be divided by something. We want it to be y minus k over b. We don't like to have anything in front of our variables. Notice y is by itself. Equals f of x minus h. There's nothing in front of x there over a. So we always want to try to change whatever's in front of x. We want to do the reciprocal in division. So the same thing as multiplying by 1/3 is dividing by 3. So we can rewrite that right away as y equals x over 3, or sorry, absolute value of x over 3. So number one, it's the absolute value function. Okay, we know that the a value is equal to 3 and the b value is still 1 because nothing's happening with the y over there. And it's h and k are both 0 because it's not being added or subtracted by anything. Okay, if we look at our parent function, We know it's normally out of 45 here. Okay, but now this is being stretched horizontally by 3. So instead of going over 1 up 1, you're going to go over 3 up 1. So that would stretch it horizontally by 3. And instead of left 1 up 1, it's going to go left 3 up 1, giving you that horizontal stretch of 3. So this red graph here, sorry, I probably should have drawn it in that color to begin with, is what happens when you stretch that horizontally by 3. Okay, time to challenge you a little bit. I want you to try to take these parent functions. I'll do the first one, you try to do the second one. See what's happening to the function. Is it being stretched? Is it being shrunk? What's going on to the parent function itself? So number one, we have to identify the parent function. So for this first one, that's a parabola, so I know that has to be the parent function f of x equals x squared. Okay, I know that normally the parent function starts at 0, 0. But this one has been shifted left 4, so I know that h is equal to negative 4, and it's been shifted down 6, so k is negative 6. So it's shifted or translated left 4, down 6, so h is negative 4, k is negative 6. Okay, and then it looks like it goes over 2 up 4 still. That's the normal way. If we go with a parabola, if we are going to the right 2, we'd go up 4 because 2 squared is 4. So A is 1 and B is also 1. It hasn't been stretched or shrunk at all. Okay, it hasn't been reflected over anything, so we can just go into our y minus k minus a negative 6 is plus 6 over 1 equals, we know the parent function is x squared, so we're going to put a squared there. X minus negative 4 is the same thing as plus 4. Okay, then we just solve it for y. So we subtract both sides by 6, and we get y equals x plus 4 squared minus 6. Okay, hopefully that's what you, or you followed that, so you can give this next one a shot. So hit pause, see if you can write the equation for the next one. Okay, first thing you needed to identify was the parent function, f of x. Hopefully you noticed that's the easy part, is the absolute value. Then this has gone over to the right 5, so h is equal to 5, and it's gone down 2, so k equals negative 2. Then it's still going over 1 up 1, or right 1 up 1, so that's a is equal to 1 and b is equal to 1 still. So that hasn't stretched or shrunk vertically, and it hasn't been reflected over the y-axis or x-axis, so we can start writing the function. So y minus k, so minus a negative 2 is plus 2 over 1 equals, we'll put over 1 this time, the absolute value of x minus h is 5 over 1. Okay, so we don't really need these bottom parts because they're 1. Alright, so then to get rid of that 2, we just subtract 2 over, so you get y equals absolute value of x minus 5 minus 2. Okay, the biggest things here is that you were able to identify what is the parent function and how is this thing translating or dilating. How is it shifting? How is it stretching? All right, if you did those things getting to the equation, we want you to get there. If you're not quite there yet, we're going to practice this a lot, and hopefully you'll get there in the next the day or so. Okay, thanks for listening. See you in class. Bring lots of questions.